In your question bank or in your suggestion, I have revised that there in five marks questions. Under the five mark questions, they are having describe the antitubercular drugs. So you have to first you have to write what is tuberculosis, then what is antitubercular drugs, the classifications of antitubercular drugs like first line and second line. Then these all are the first line drugs like rifampin, isoniazid, pyrazinamide, and ethambutal. So you have to write the mechanism of actions like this. Only one line. This is enough for the 5 marks. So all you understand what you have to write for that question, that antitubercular drugs. So here I am starting with the mechanism of all first line tubercular drugs or antitubercular drugs. First come the rifampin. Rifampin, it is a semi-synthetic derivative or rifamycin B, which obtained from Streptomyces mediterraneae. Rifampin is bacterial to bactericidal. Bactericidal and bacteriostatic. Bactericidal means which kills the bacteria, and bacteriostatic means which resist or which prevent the bacteria, but not kill them. Bactericidal means which kill the bacteria. So rifampin is bactericidal. That means which kills this microbacterium species, and many other gram-positive and gram-negative bacteria like Staphylococcus aureus, uh, influenza, E. coli, Klebsiella, etc. So this rifampin, the mechanism of action is like that it inhibits DNA-dependent RNA synthesis. Okay, binds with RNA polymerase and block the RNA synthesis. DNA-dependent RNA synthesis. Okay, here the bactericidal sterilizing activity due to activity against semi-dominant dormant bacteria. So the mainly mechanism of actions, like in which way the rifampin works in our body. Rifampin inhibits DNA-dependent RNA synthesis. Probably the basis of selective toxicity is that mammalian RNA polymerase does not avidly bind rifampin. Mycobacteria and other microorganisms develop the resistance to rifampin rather rapidly. Okay, so this one line is enough. Binds to RNA polymerase and blocks the DNA dependent RNA synthesis. So R, what does the rifampin what do the rifampin work? How does the rifampin works? This rifampin blocks the RNA synthesis. RNA binds to RNA polymerase, RNA polymerase, and blocks the DNA dependent RNA synthesis. It is bactericidal, sterilizing activity. This have sterilizing activity due to activity against semi-dormant bacteria. Then comes to isoniazid. This mainly inhibits the mycolic acid synthesis. Isoniazid is antitubercular antitubercular drugs par excellence and an essential component of all antitubercular regimens unless the patient is not able to tolerate it or bacilli are resistant. It is primarily tuberculocidal, and first multiplying organisms are rapidly killed, but quiescents one are only invited. It acts on extracellular as well as on Intercellular tubercular in which bacilli present within macrophages is equally active in acidic and alkaline medium. It is one of the cheapest antitubercular drug. However, most atypical mycobacteria are not inhibited by isoniazid. So, what is the mechanism of action? Most plausible mechanism of action of isoniazid is inhibition of synthesis of mycolic acids. So it inhibits mycolic acid synthesis. Okay. Most plausible mechanism of action of isoniazid is inhibition of synthesis of mycolic acids, which are unique fatty acid components of mycobacterial cell wall. So what are the mycolic acids actually? Mycolic acids are the unique fatty acids components which are present in mycobacterial cell wall. So this mycolic acids is a component which is present in mycobacterium cell wall. These are present in mycobacterial cell wall, and isoniazid inhibits this mycolic acid synthesis. This may explain the high selectivity of isoniazid of mycobacteria. It is not active against any other microorganism. The lipid content of mycobacteria exposed to isoniazid is reduced. So, lipid content or the mycolic acid, which is reduced for inhibition of mycolic acid synthesis. Okay, a gene labeled isoniazid, isoniazid A, which encodes for a fatty acid synthase enzyme, is the target of isoniazid action. The sensitive mycobacteria concentrate isoniazid and convert it by a catalase peroxidase enzyme into an active metabolite that interacts with isoniazid A gene. Isoniazid is completely absorbed orally and penetrates all the body tissue. It is extensively metabolized in liver and most important pathway being acetylation.